We are observing a localized ecosystem where standard biological rules have been discarded. Predators here bypass traditional hunting cycles, consuming their own mass. The local pests exhibit a similar defiance of nature. They demonstrate the ability to hollow out solid tomatoes to construct functional entryways, and appear to manipulate the cellular structure of simple root vegetables at will. A resident mouse, attempting to maintain a standard crop cycle, now faces an existential threat from this hyper-evolved swarm. This is no longer a recognizable predator-prey dynamic. The environment has shifted into a state of erratic biological behavior, defined by unpredictable mutations and a lack of ecological constraints. To protect the harvest, the mouse initiates a conventional defense protocol, applying standard chemical insecticides across the infested fields. The swarm responds with a coordinated evasion tactic. By pulling the topsoil together, the insects physically zip the ground shut to shield themselves from surface-level exposure. This cross-section illustrates the limitation of the mouse's strategy. The chemical spray contacts the top layer, leaving the pests entirely untouched in the protected void beneath the barrier. With surface-level chemical warfare proving ineffective, the mouse pivots toward a more aggressive, experimental biological agent. The farmer's role shifts from cultivation to chemistry. He begins engineering a custom, high-concentration toxin designed for permanent eradication. He selects a manual, high-pressure liquid projector, a standard water gun, as the primary delivery system for the compound. To understand the risk, we must look at the tool's fluid dynamics. The pump mechanism forces the chemical from the main reservoir into a secondary firing chamber, where it is held under manual pressure. Combining a highly volatile biological agent with a manual, pressurized delivery system creates a volatile scenario, especially when it's deployed without technical testing. A mechanical failure occurs at the nozzle. A solid blockage forms in the barrel, trapping pressurized chemical. To clear it, the mouse inserts a thin wooden rod. This pierces the obstruction, but dangerously compromises the internal pressure seal. At this critical moment of mechanical instability, a dog enters the immediate vicinity. The sudden presence of the larger animal triggers an instinctive startle response. As the mouse flinches, the kinetic energy from the movement transfers directly into the already unstable, over-pressurized device. The seal fails. The chemical compound erupts backward, completely dousing the mouse in his own experimental toxin. This disaster resulted from a specific sequence of user error, mechanical obstruction, and a sudden external variable. The chemical reaction is immediate. The mouse experiences an onset of acute neurological dizziness. This is quickly followed by a radical physiological shift, a rapid and continuous reduction in total physical mass. This low-angle view demonstrates the shift in scale. To the shrunken mouse, ordinary blades of grass now have the towering height of massive redwood trees. The toxin successfully reconfigured the biological scale of the environment, but it effectively targeted the creator rather than the pest. The insect swarm encounters the remaining toxin. Rather than being eradicated, they consume the compound as if it were a nutrient-rich beverage. The resulting mutation turns the toxin into a super serum, granting these pests the proportional strength of 20 elephants. We can map the divergence on this chart. As the mouse's physical mass drops toward zero, the insect's power levels climb exponentially. By forcing an extreme chemical solution onto a complex ecosystem, the mouse has effectively engineered his own apex predator.